Alright guys, this video we're just going to go over basic definitions of different types of number sets that we're going to work with throughout the whole year. Main thing with this video, we're just going to take down the definitions and I'm going to give you a couple examples as we go. If we look at the first one, we have real numbers. Real numbers, if I just draw this right here, well that's an awful line, but we know if we draw a real number line, we have 0 in the middle and then we'll have positives to the right, negatives to the left. And anywhere in between, like if I pick a number here, here, any number in between are all decimals or fractions. A real number is any number that can be written on the real number line. Could be a fraction, could be negatives, could be whole numbers. So any number we deal with this year, it's going to be a real number. So make sure you take that down. Okay, then if you look how I have this written, if you look at the left side, so number 2, number 4, 5, and 6, these are all examples of basically rational numbers. And then I'm going to cover number 3. I'm going to do that last. Okay, let's look at number 2. I'm going to kind of zero in on number 2 here. Okay, let's make this bigger. Alright. Alright. Alright, so rational number. We have this right here. This is any number that can be written as a fraction. Alright, and it includes repeating decimals. Alright, here's an example. So, here's the main thing. Within rational, we have the word ratio. Ratio is the same thing as a fraction. Here's examples. Right, I could take any fraction, 2/3. I could make it negative 2/3. If you have a whole number, some people forget whole numbers. Let's say you have 4. Students might look at it and say, well, that's not a fraction. But really, if you have a whole number, you can put it over 1. So that also includes whole numbers. And if you have a repeating decimal, for example, if you had 1/3, that, if you did 1 divided by 3, that's 0.3 repeating. Another way of writing that is 0.3, and you have the bar over it. So if you have a long, ugly decimal, but it repeats, it's also rational. So any number that can be written as a ratio or a fraction, we say is a rational number. Okay, I'm going to do 4 and 5, and then I'll go back to number 3. So anything, really, 4, 5, and 6, the natural numbers, whole numbers, and integers, these are examples of rational numbers. Okay, number 4, we call this natural numbers. Another name for this, as we call this, is the counting numbers. Okay, reason why we call it the counting numbers, when you count, you always start with the number 1. So it's just the positive whole numbers. So it's just 1, 2, 3, 4, 5, 6, and you keep going. So you never count with negatives, or when you count, you never include the number 0. Okay, the next one, whole numbers, it's almost the same exact thing, except you include 0. So it's 0 and all the positive whole numbers. So whole numbers are just 0, and then all the positives, 1, 2, 3, 4, 5, 6. And then you keep going. Okay, when you go down to integers, then you keep adding on to it. Integers, you add the negatives. So let's move this up. So integers, these are the positive and negative whole numbers. So make sure to take this down. So I can go, let's see here, I can go forever. Like these dots mean it go forever to infinity. Well, if I include negatives, that could go to negative infinity. So I'm going to put the dots. Then I'm going to put -3, -2, -1. I also include 0, and then all the positive whole numbers. And that goes to positive infinity. So with all of these, with natural numbers, whole numbers, and integers, we're not dealing with any decimals. These are all whole numbers right here. Okay, little discrepancy as we go. Natural numbers are just the positives. Whole numbers, you put 0 into it. Integers, you include the negatives. All right, and the very last thing, let's move over here. It's kind of by its lonesome here, the irrational numbers. I have it in a different color because if it's irrational, then therefore it's not rational. So it can't be a natural number, a whole number, or an integer. Alright, so for this we have, it cannot be written as a fraction. So it can't be written as a ratio. And really what these are decimals that go on forever and they don't repeat. Alright, so you can't write as a fraction. The most famous example, take this down, is pi. Now I know pi, we usually round that to 3.14, but if you actually put pi in your calculator, I'm not even sure exactly what the decimal is, but it's like 3.14156793. I don't know what it is. I could be just making that up. But that's a long, ugly decimal, and it doesn't repeat. There's no pattern to it. So if you say like someone's acting irrationally, there's no pattern to their behavior. Same thing with this. Right? If you have a number that is a long, ugly decimal and it doesn't repeat, then it's irrational. All right, so those are just the definitions. We went over some examples. We'll talk about more examples of this in class.